So yeah, my name is Denis. I lead developer experience at ZetaChain. I don't know if you were at the keynote earlier today, but I'm gonna still give a intro to what ZetaChain is, what it can offer to you as developers. Because first and foremost, it's a service to developers, right? It's up to you if you want to leverage that kind of functionality in your dApps. But ZetaChain is a L1 EVM compatible chain that focuses on interoperability. So it facilitates, it provides a platform for developers to build dApps that are cross-chain by default, right? So it's not something that you add to your dApp later on. It's something that your dApp is built from the grounds up. So interoperability is actually a pretty hard problem to solve. I'm coming from the Cosmos ecosystem background. I've been contributing to it since 2019, and it's one of those ecosystems that really advanced in interoperability. Right, there are over 60 connected blockchains right now, but it's still very hard to build dApps that are interoperable, right? We have interoperable blockchains, but how do you build actual dApps that can talk to contracts on other chains, that can facilitate cross-chain token transfers, cross-chain NFT transfers, these sort of things? So that's what ZetaChain offers. So we have two tools for developers. One is cross-chain messaging, and one is Omnichain contracts. I'm going to start with Omnichain contracts just because I think it's a more exciting tool and a radically different approach to how to build cross-chain dApps. I'm going to show some code. Probably not going to code anything right now, but by the end of this workshop, you should have a pretty good understanding on a high level what it takes to build a dApp that is Omnichain by default. So let's get into it. ZetaChain, as I said, is an EVM chain. So the toolbox that you have at your disposal is similar to if you were to build an Ethereum dApp. So we're just going to do that. Let's open a terminal. Imagine you don't have anything installed, right? You just have your terminal, a Unix-like system, and what you do is you clone a template from ZetaChain's GitHub. We have ZetaChain/template, or we have it cloned, creates a new directory. Let's open and see what it contains. It contains actually a whole bunch of nothing, right? It's just imported files from other repos, but it sets you up for a good start developing contracts. Just type yarn. It's going to install all dependencies. And it's using Hardhat, so it's very familiar if you're ever built anything on Ethereum. But in addition to the commands that Hardhat offers out of the box, we added some new ones that might be useful to you. So for example, if you don't have an account, you can type Hardhat account. It's going to create one. You can type save to save it in .env. I already have an account there. It's not going to do that, but after doing that, you might want to run faucet, and it will query tokens from ZetaChain. After you get some tokens, that's something you need because Omnichain contracts are deployed to ZetaChain, so you need Zeta tokens for that. After you do that, you can query balances. This is just some basic kind of infra tooling side of things, but hopefully it might be useful. My internet connection is not that great. So here you go, all the balances. And you can see all the chains that ZetaChain right now supports. We have 3 EVM chains, Polygon, BSC, Ethereum, and we have Bitcoin as well. So let's try to actually create an Omnichain contract. How does it look like? Right? We have also a tool for that. I mean, I'm responsible for tooling, so I'm kind of proud of the tooling we have. So that's why you see a bunch of it. But it really makes the process simpler, and it removes a bunch of mistakes that you can make if you try doing it manually. So we have a command called Omnichain, and it just creates a new contract for you and all the tasks you need. So let's call it my contract, and it accepts fields that I will talk about later what those fields are. But let's say the first field is just foo, and it's going to be of type address. We have token amount is going to be of type uint 256, and let's say a description of whatever default type. Okay, so now you can see it created 3 files for us. One is the contract and 2 helper tasks, right? So this is a very basic but functional Omnichain contract. And let's go kind of line by line to see how it differs from a regular Ethereum contract. Hopefully you can see the code. Let's even make it bigger. So it's just a contract that inherits from ZContract. Has a system contract address passed to it from a constructor. System contract is just a helper contract on ZetaChain that contains addresses and whatnot to help you write your contracts. But the most important thing is this on cross-chain call function. Your contract can have a bunch of other functions, but this one is special. This wasn't special because it gets called whenever a user on one of the connected chains tries to trigger your contract. And let's actually try to play with it and then see how the pieces are connected. For some reason, the network is super slow right now. I looked it up, and we have like hundreds of transactions going on every single block. So let's hope it works. So I compile the contract. Now I want to deploy it to ZetaChain. Might take a while. So again, this function is your kind of entry point to your contract. When a user wants to interact with your contract from Ethereum, they can do that very easily. Okay, we have a contract deployed. Let's try to interact with it. So we have an interact task here, npx hard hat interact. Let's see, help. So all the fields that we passed, it accepts it as input. So these are actually the arguments of your contract on cross-chain call function, right? It's the content of the message that will be passed from a connected chain. So let's say for amount, we're not going to send anything. Contract is the contract we just deployed. And description is going to just be hello. Foo is of type address, so I'm just going to use my own address here. And network is going to be Goerli testnet. Okay, I forgot token amount. Should be, I don't know, 2, 3, whatever. Doesn't really matter. Our contract doesn't do anything yet. I just wanted to make for you to have this kind of mental connection between what's happening on Goerli and what's happening in your contract. So we've broadcasted a transaction on Goerli. Let's check it out. So this is the data that you're passing. So when you're sending, like when you deployed your Omnichain contract on ZetaChain, now any person on any connected chain can actually trigger your contract and pass value to it by sending a native transaction on this chain. So we've sent a transaction on Goerli, and we passed a bunch of data as input data. This data gets passed as a message to on cross-chain call. You can decode it, and then you can use it any way you want. So this is super powerful because it allows users to remotely trigger your contract from any connected chain, including Bitcoin, by the way. So what this provides is a platform for developers to build contracts that can be easily triggered by Bitcoin holders natively from Bitcoin. Instead of input data, they're using a memo for that, but it's exactly the same. So they're also passing data in a memo. They're including BTC. They're sending a transaction, and your contract on ZetaChain gets called. You can do all sorts of things with it. You can implement staking. You can implement DeFi protocols natively for Bitcoin. So we covered data, right? It just gets packed, transferred, and then your contract accepts it as a message. Then you can decode it. The way the system knows which contract to call is by first 20 bytes, right? So all the transactions, when you're doing these cross-chain calls, you're always sending these transactions to the same address called TSS. And the system kind of relays this information to ZetaChain. And then based on the first 20 bytes of the input data, it decides which contract to call. So this address is actually the contract address on ZetaChain. The rest you can think of arguments to this contract call. So we covered data, pretty straightforward, right? It's like remote procedure calls on regular servers, right? Imagine each blockchain as a server, and you can make a RPC request from one server to another, and you can pass data. What about value? So you can also pass value to it. Here we didn't send any ETH, but we could have sent like 2 ETH, for example. What would happen then is these tokens will be locked in this TSS address, which is the entry point to ZetaChain from a connected chain. This TSS address is not a contract. That's why we can support Bitcoin, for example. It's a regular address, and the private key for this account that is represented by this address is owned by validators of ZetaChain. So the private key is split into fragments, and validators collectively sign transactions that come into ZetaChain and go out of ZetaChain. And this happens through this TSS address on each chain. So that's why we can support Bitcoin, Dogecoin, any legacy chain that doesn't support smart contracts pretty easily. So when these tokens are sent to this TSS address, they're locked in this address, and wrapped versions of these tokens are minted on ZetaChain, and they're passed to your contract. So you can see that you have a message, but you also have 0C20 address and amount, and that's exactly for these tokens that gets transferred. So for ETH, for BTC, for Matic, wrapped versions are minted and they're deposited into your contract. So what your contract can do with them is a very simple example is cross-chain swap. Of course, this platform is general purpose. As you can see, it's just Solidity. You can write anything you want, but cross-chain swap is just an easy example where we have internal liquidity pools, but you can use something like SushiSwap, for example, that is deploying on ZetaChain right now. And you can use their DEX to swap these wrapped tokens. And when you swap, for example, right, you get as input, for example, ETH. In your contract, you get a wrapped version of this ETH. Then you swap for a wrapped version of BTC, and then you can withdraw it back to Bitcoin. So in a single transaction originating from Ethereum, a user can actually swap their assets to Bitcoin or to any other network. They can easily move USDC, for example, or any other ERC20 token from Ethereum to Polygon or back. Like, they can do all these sort of things. You can also implement pretty interesting protocols, like for Bitcoin staking. I know it's very popular these days. A lot of projects are working on kind of adding utility to Bitcoin, sort of do something towards BTC, right? Right now, a lot of value is locked on Bitcoin, but it's not really doing anything. So if you go to our docs, you can find staking tutorial, how to implement. I mean, it's very basic. It doesn't produce yield, right? It kind of just mints tokens, but it's up to you to kind of figure out how to produce yield for holders. Maybe you, I don't know, swap for another token and then move it to a different protocol, do something there, and that's how you can generate. But you can still see that that it's a pretty small contract, right? It's around, I don't know, 200 lines of code, and what you get is a system that can accept BTC or any other token as input based on the amount of BTC that you deposit. You mint new tokens, and then you can withdraw these deposited tokens from Bitcoin. And that's why we emphasize the fact that it's not about wrapped assets, but rather about like native assets, especially native Bitcoin. Of course, the contracts don't run on Bitcoin, thankfully, right? Because we have a proper EVM for contracts. But from users' point of view, they deposit tokens on Bitcoin, and they can withdraw tokens again on Bitcoin without having a ZetaChain wallet, without even knowing about ZetaChain. They can interact with DeFi dApps directly from the chain that they are using. And that's actually a pretty important thing for regular end users, right? So they can natively interact with the chain of their choice, but also kind of play with DeFi protocols deployed on other chains. So using SushiSwap natively from Bitcoin is going to be possible as soon as they integrate, which is going to happen closer to mainnet. So yeah, that's about Omnichain contracts. I can quickly review stake swap example as well. Let's check it out. Where is it? Okay, it's here. Not this one. So in the example contracts repo of ZetaChain.org, we have some examples. Swap is one of them. Let me see. So it almost fits on one screen. It's pretty simple. So this is the contents of one cross-chain call. I'm kind of skipping over the boilerplate code here. But to implement a cross-chain swap, you just need to kind of implement data decoding logic for Bitcoin and for other chains. It's different because on Bitcoin, you want to be very conscious of the amount of data you're actually putting into the memo. So you would be encoding it manually. It's easier than it sounds. You just kind of smush all the data together. And then on the contract side, you just use our helpers to decode raw bytes into something more usable on EVM side. So here we have just two arguments. So when you're swapping from Bitcoin, you're passing BTC as input, and in the memo, you're including the token that you want to swap to and the recipient address. Recipient address is actually non-optional here because when you're swapping from Bitcoin, you actually need to provide your address on another chain. You don't even have, like, a user doesn't need to sign anything. They just need to know that they have an address on another chain. And that's it. And using helpers, you decode these two values. For EVM chains, you just use ABI decode. Then you're using our helper to swap using the internal Uniswap pools, but you can swap, sorry for pun, but like, you can replace this with a different implementation for a swap and use any other DEX that you want. And then you just use the withdrawal method of the token. So the wrapped tokens that you get deposited on ZetaChain are called ZRC20, which is a small extension of ERC that adds a few functions. One of them is withdraw. So any holder of a wrapped assets, let's say wrapped BTC, which is ZRC20 BTC, they can just press a button to withdraw, and the process will start to move these wrapped assets back to Bitcoin in native format. So it's very straightforward for any holder. You don't even need to interact with the contract, any other contract than the token, other than the token contract. Just press withdraw, and your tokens get back native on your on the origin chain. So that should cover Omnichain contracts. I know it's a lot of information, but like hopefully I'm adding more and more kind of diagrams that can help understand what goes under the hood. But basically, again, the advantage of Omnichain is that you deploy a single contract and you support all the chains. So that's it. And I think it's huge, because we're gonna have, I strongly believe in this vision of the future where we have hundreds and thousands of chains. It's hard to come up with a architecture that is scalable to thousands of chains. Cross-chain messaging is not scalable because you would have hundreds or thousands of contracts to worry about. You'll have to update them. You will have state spread between hundreds of chains. Nobody wants that. That's probably the worst possible segue to the point that we also support cross-chain messaging. But we do that for those dApps who really know what they're doing, and they know that they want cross-chain messaging. We have that as well. But we think Omnichain contracts is the future. It's one of the most scalable ways to build dApps that are scalable to hundreds and thousands of chains, and that are compatible with all the existing chains and the future ones. So going back, ZetaChain is a Cosmos-based chain, which I think is pretty cool, because I also think of it as a way to kind of make even more chains interoperable. So Cosmos right now is connected to all the chains within it. Of course, it's also now connecting to Polkadot, to Avalanche. It is connected to Bitcoin somehow, but it's not as fast and it's not as interoperable. It's just for wrapped Bitcoin. Here, what you get is also a platform where you can utilize this wrapped Bitcoin without wrapping it more, right? So with the solutions that we have in Cosmos, tokens are, when they move from Bitcoin to Cosmos, they get wrapped. If you want to engage in some sort of DeFi, you need to doubly wrap them by moving through IBC, which is acceptable, but this solution is much better, because not only do you get native wrapped Bitcoin, native wrapped is a bit of a, but anyway, you get my point, right? That's like the shortest route from the native Bitcoin to a platform where you can build dApps using a capable system like EVM, not having to move this asset any further. So yeah, I'm not going to go into the details of cross-chain messaging. It's a bit off topic here, but very quick overview. It supports EVM chains, doesn't support Bitcoin, obviously, but it allows you to send arbitrary data. So right now, Omnichain contracts are for fungible tokens. We're going to be adding NFT support next. The reason why we can't support all data types is because for each data type, we need to know how to connect it to Bitcoin, for example. So we did that for fungible tokens. For NFTs, that would be a separate module, a separate set of functionality, because we need to kind of connect the format of NFTs, that the way they exist on Bitcoin, to NFTs the way they exist on EVM. And we'll add more and more data types as we go, but this is already incredibly functional for dApps that use fungible tokens or any sort of DeFi apps, and also a very cool platform for adding functionality to Bitcoin. We have ETH India hackathon later this week, I believe. Have several tracks. One of them is actually Bitcoin, so you can come up with a new way of leveraging BTC and adding utility to it. So yeah, I guess it ended up being a bit shorter, but I know there are questions in the audience, so I wanted to leave some time for questions. So yeah, please go ahead.
So how does a normal bridge and ZetaChain? So if I'm just using a normal bridge, right? You ideally lock the assets on one chain, mint that entity, which is the bridge, mints that wrapped asset on another chain. So how is that different from what ZetaChain is doing right now?
Yeah, good question. So there are bridges out there that do something similar. The difference is ZetaChain is trying to improve on design of it, right? So with bridging, you often get smart contracts on both sides. So if you're moving assets between EVM chains, you have a smart contract bridge on one side, smart contract bridge on another side, and this opens up a lot of areas for attacks, and that's where bridges often failed. So with ZetaChain, you actually have an address, and it's pretty hard to hack into an address unless you get access to a private key, right? That's the beauty of on-chain accounts, is that
There's no code to hack in terms of an address.
Sorry?
There's no code to hack. There's no smart
Yeah,
contract.
the only way you can hack a TSS address if you bribe validators to give up their fragments of a private key, and you have to bribe a lot of them to get enough of the fragments, right? And that's going to be problematic. And the second thing is that ZetaChain is its own L1, right? So it's a sovereign chain with its own set of validators, its own consensus engine. And all the transactions that are going through ZetaChain are very easily tracked. So you can clearly see in real time which validator signed this transaction, didn't sign this transaction. Incoming and outgoing. It's as transparent as it can possibly be, because all the actions that validators and users take and are there on chain. So it's completely traceable, trackable, transparent. So that's an advantage. Another advantage is Bitcoin. It's a pretty big advantage that, like, if your bridging solution depends on you having a contract on a counterparty chain, how are you going to do that on Bitcoin? It's probably going to be pretty tough to implement.
So wrapped Bitcoin would technically have a normal address on Bitcoin chain and a smart contract on the EVM chain, right?
No, with ZetaChain, you have TSS addresses on all the chains. So that's what makes it much more secure, is because it's just an address. On Ethereum, it's just an address. On Bitcoin, it's slightly different for ERC20 tokens. There's a very small contract that holds custody of ERC20 tokens, but it's the code is like, I don't know, less than 100 lines of code. It's just custody, so it's pretty much the same. It's been audited like 1 billion times, but that's kind of the only thing you need, and it's easier to add more chains because the only thing we need to do is deploy a new an address to this chain and coordinate with validators to support that chain, and make some small adjustments to how validators watch for events if it's different from any other blockchain.
So on the native chain, when you send Bitcoin, let's say 1 Bitcoin to the TSS address, right? There's obviously cross-chain communication where you have a TSS address on, let's say, Ethereum, and then you mint a particular TBTC or something in terms of ZetaChain.
So we're not dealing with wrapped Bitcoin outside of ZetaChain. So the way it works is, if a user wants to move value from Bitcoin to Ethereum, they're gonna have to choose a token on Ethereum that already exists, right? So it's not going to be wrapped Bitcoin, and that's pretty much because we don't want people to depend on wrapped tokens on the destination chains, because then they depend on security of ZetaChain kind of forever, for as long as they have this wrapped assets. So what we would rather do is facilitate kind of transactions that swap tokens for the tokens that you want to get. And the same, of course, goes for Bitcoin as well. If you're moving like USDC from Ethereum and you want to move this value to Bitcoin, you're going to get BTC, because that's the token you want to hold on Bitcoin. Any other questions?
So you mentioned DeFi on Bitcoin, right? So that again will happen on ZetaChain?
Yes. So it's gonna so to implement any kind of DeFi for Bitcoin, you would write a Solidity contract, deploy it on ZetaChain, and the cool thing is that this contract is gonna can accept BTC or any other token of any connected chain as input. So yeah, it is wrapped Bitcoin on ZetaChain. That is true. Can't really go around that, right? You can't physically move BTC unless you burn it, but I don't think anyone wants to do that. So you would have this token on ZetaChain. It's kind of like a representation of it during the transaction. So for many transactions, for example, cross-chain swaps, users should never really encounter wrapped assets at all, because all they're seeing is one native asset kind of transforming into a different native asset on a different chain.
Any thoughts about Circle's CCTP route, where they issue the tokens natively on all chains?
Yeah,
apart from Bitcoin, Bitcoin we can't do it.
Pretty cool. I just recently used it to move USDC from Osmosis to Ethereum. Much better than some other solutions. I don't know how decentralized it is, and it's only for USDC. So I think like integrating with Circle is a nice thing to do if you're a chain. Like I think we would integrate with Circle just to kind of make these specific transactions a bit faster. But at the same time, we still want systems that are kind of truly end-to-end decentralized. Even for moving USDC, you might want to use a decentralized solution for this, which ZetaChain can offer, right? And of course, there are other tokens, other applications. So yeah, I think CCTP is a good kind of specific use case solution, but here we're talking about more of a general purpose platform. Yeah. Any other questions?
One last, if I may.
Yeah, of course. Great questions. Go ahead.
So cross-chain messaging is something which is completely different, right? Why is that not the future instead of wrapping assets on different chains?
Yeah, I feel bad about cross-chain messaging because they didn't talk enough about it, but that was a bit off topic. So ZetaChain does offer cross-chain messaging, where between EVM chains you have contract on one chain, contract on another chain, and you send a message from one chain to another. Arbitrary data, you can send data about NFTs. So that's, until Omnichain supports NFTs, that's the go-to way of moving NFTs between chains if that's what you want. It's okay. A lot of other projects are focusing on cross-chain messaging as like the go-to tool for cross-chain. We just don't think it's scalable because you need to maintain contracts on these tens, like dozens and hundreds of chains, and your state is spread out as well. With Omnichain contracts, your state is in a single contract, and that's so much easier from a developer's point of view, right? Try to support 50 chains with cross-chain messaging. Like it becomes a nightmare to update all of them and like synchronize all these bits and pieces spread out between chains. That's one reason we don't think cross-chain messaging is gonna be like the go-to tool. The other reason is that there are fewer opportunities for kind of scaling this, because if cross-chain messaging offers the arbitrary data transfer, you don't really know what this data is, right? So unless these cross-chain messaging solutions offer kind of separate kind of lanes or separate routes for different types of data, there are very little opportunity. With Omnichain contracts, we can optimize this even further. It's cheaper than cross-chain messaging, but we can optimize it further by instead of processing every single incoming separately, we can batch them, and that's gonna be a huge improvement. We can do all sorts of things with outbounds as well. So just the potential of how we can kind of optimize it, I think it offers so many advantages over messaging.
Thank you.
So as a dApp owner, so I can deploy my dApp on ZetaChain, right? And then to access it, to give the user access it from, let's say, Ethereum, I just need to call the TISS address on the Ethereum, right?
Yes. So if I got your question, yes, you do deploy a contract on ZetaChain, and to call this contract, you send the transaction on Ethereum to a TSS address, and ZetaChain's validator infrastructure provides the transport layer for these bytes to ZetaChain.
So how is the gas things work in this case? Because the transfer of the data is just on the Ethereum and not on the ZetaChain for the user as per. So how is the gas thing being handled? Like,
yeah, great question. So when you send tokens to a TSS address, it's really up to you to pay gas, right? So that's on the user. Depositing tokens to ZetaChain is free right now. I think there are parameters to kind of increase that, like change that, but right now, like there's no technical reason we should charge. It's up to the community of the blockchain to decide. Okay, we're getting so much traction, so much traffic. We might add a fee that will go to the community pool to then develop a chain. That might be the case, but right now depositing tokens is free. However, when you are withdrawing tokens, it's up to, I mean, it's not up to, but like the burden of paying gas fees on the destination chains falls onto the protocol, right? So if you're moving Matic from Polygon to Ethereum, what you get in the end is a transaction from a TSS address to a recipient address, and someone has to pay these $20 per transaction. That gets deducted from the tokens that you're withdrawing. So on ZetaChain, we're swapping the tokens that you're trying to withdraw. We first see if it's enough to cover cross-chain fee, this fee that that we're gonna have when we're withdrawing. If it's enough, then this a part of your amount gets swapped for native gas token. It gets burned, and the rest is withdrawn. Yes, we have a bunch of explorers. I'm personally kind of partial to this one, which is called ZetaScan, developed by the team. So explorer.zetachain.com. We have Block Scout as well, which is, so ZetaScan is kind of better for cross-chain stuff because it's specifically for ZetaChain. Block Scout is a bit better for debugging EVM side of things. So I use both. We also have tooling on the CLI side, which you can just execute a command and it will track your transaction going between chains. And you can use it from a front end as well, which I'm super excited about because I'm in the process of building a front end for people to see how easy it is to build dApps for ZetaChain as well.
Because if I have to build something like this, so I have to track all the nodes that are there out there.
Sorry, can you
if
speak
I
up
have to
a bit?
build an explorer like this, for example, ZetaChain as some sort of RPC node as such, so I can call.
Oh yeah. All of this is in our docs. So if you go to the docs, you can go here, tools, API RPC endpoints. Hopefully, my internet connection allows fetching this dynamically from GitHub. Eventually. what you would see on a normal internet connection is a table with endpoints. There are going to be a lot of them because it's a Cosmos-based chain. So it's both Cosmos API endpoints, consensus engine endpoints, as well as regular EVM endpoints. So it's using Ethermint Cosmos SDK module, so it's very compatible with Ethereum. So pretty much anything you can run on Ethereum gonna run on ZetaChain, as is courtesy of Ethermint. And yeah, you can use MetaMask. I forgot to mention you can use both Cosmos wallets as well as Ethereum wallets. Like the wallet of choice right now for developers is MetaMask. So you can for Bitcoin it's a bit different. Don't have MetaMask for Bitcoin yet, but we have XDeFi, which is pretty good. The only thing a wallet needs to support for it to be able to send transactions from Bitcoin to ZetaChain is memo support, and the format is very simple, just bytes basically. But yeah, XDeFi, Xverse, a bunch of others support it. Yeah, do they have a snap for Bitcoin? Oh, well, now you can use MetaMask. You don't have to leave MetaMask ever. What a world. But no, I mean, that's, of course, it's much easier for end users because they can have one wallet. That's actually like fits very well into the vision of ZetaChain, because we don't necessarily want to require users to have ZetaChain wallets. They might have just like their Polygon wallet and that's it. But they still interact with dApps on ZetaChain.
So one thing would be, so let's say I'm transferring USDT from Ethereum to ZetaChain, or my dApp on ZetaChain. So USDT on Ethereum and USDT on Polygon have different addresses.
Yeah.
So how is that? How will I get the address on Zeta? My smart contract, how will it identify that it is the same USDT, whether it is from Polygon or it is from any other network?
Yeah. So let's say you want to move an arbitrary token from Ethereum to Polygon, and let's say it's USDC or USDT or whatever foo token. You're depositing this token, like let's say USDC, right? You're sending USDC to your TSS address. It gets locked. You get a wrapped version of Ethereum-specific USDC on ZetaChain. Then through the magic of liquidity pools, you just swap it to whatever wrapped version of the destination asset you want. Let's say that's a Polygon-specific version of USDC. You're going to swap it to that, and then you're going to withdraw it back to Polygon. So in the end, you're going to get USDC native token on Polygon. That's it.
So this depends on the developer who actually is designing the contract, not anything to take with ZetaChain.
Come again?
So whatever he said, if I deposit and then convert USDT to USDT on Polygon, Ethereum to Polygon, I as a developer has to design the contract such a way that the addresses are mapped properly.
You
Or is it something that ZetaChain
you don't need to do the mapping. You just need to swap it to the destination tokens correctly. So if I understand this correctly, like as a smart contract developer, you don't need to maintain these mappings. You just look up which token you want to get in the end and use one of the dexes we have to swap these tokens. And then you just call a withdrawal method on this wrap token. It gets pushed back to the destination chain.
So just to clarify, let's say the Polygon on USDT, the USDT on the Polygon would have address A on Zeta, and the USDT on Ethereum would have address B on Zeta, and that is how you swap them. Basically.
Yeah, you can think of it like that. So different tokens from different chains have different wrapped token addresses on ZetaChain. You just swap between them, and that's how you get from point A to point B.
I also have one thing. I want to ask one thing. Like, let's say I already have a dApp, okay, which is deployed on some network. Now, if I want to create it Omnichain, so I have to create a new contract, or the same contract can be deployed, or somehow can be modified so that it can become a Omnichain contract.
Yeah, so you take your dApp, you take your contracts, you bring them to ZetaChain, you deploy them, and there are two options. You can modify the contract, and the only thing you need to do is add this on cross-chain call functions. You can have a billion functions before that.
Yeah.
Like, doesn't matter. You just inherit from Z contract and implement this function, and that's it. So that's not one option. Many projects opt in for like a different option where you have a separate contract that is responsible for cross-chain interactions. This way, you keep your contract unmodified, and you deploy a separate contract that it has on cross-chain call, and then it just calls your contract. The only thing your contract will need to do is be able to talk to your C20 tokens, which, if it is, because the wrapped versions of assets on ZetaChain are ERC20 compatible.
Got it. So just to be clear, this on cross-chain call function under the hood actually using the ZetaChain cross-chain bridge, right?
Yes, this is just a function that gets called by the protocol whenever someone tries to access your contract from a different chain. That's it. There's not much special about it. It's just a name that we settled on that gets called.
So under the hood, this on cross-chain call function is actually using ZetaChain cross-chain messaging, right?
It's not using messaging. It's using think of it like it's the function in your contract that gets called. Yeah, I mean it's using ZetaChain validators, Omnichain infrastructure. You can call it any way you want. It's like it's a hook. It's a kind of a handler that gets called.
Let me rephrase the question. The question I want to ask is, at what time a developer should use the cross-chain messaging, and at what time the developer should use a Omnichain contract?
So if right now Omnichain supports fungible tokens, so if you're building a DeFi dApp, right, lending, borrowing, staking, swapping, anything that deals with fungible tokens, strongly recommend Omnichain contracts. Just much better, architecturally wise, much simpler. If you deal with NFTs right now, I would go for cross-chain messaging. When Omnichain supports NFTs, I will change my mind and recommend the other thing. But if you need arbitrary data, for now, cross-chain messaging is the way to go. So what ZetaChain offers is kind of similar. And in that department, what ZetaChain offers is similar to what other projects offer in terms of cross-chain messaging. But Omnichain is quite a bit different.
Okay. Now I have one more final question. Sorry.
Yeah.
So the final question that I have is, I know it might be absurd, but I want to know. Okay. The question is, let's say I deploy a simple contract over ZetaChain, and I do cross-chain with any service, let's say Chainlink cross-chain, or let's say Hyperlane, or I use ZetaChain Omnichain. Okay. So what will be the difference there, and how it will be affected on my dApp?
So the difference is basically, again, we're kind of going back to comparing cross-chain messaging and Omnichain.
Correct.
So with cross-chain messaging, it's more expensive. It's more dangerous because you have contracts on both sides, and it's more harder to manage. Here, okay, think of like you deploy a contract on ZetaChain, and it's compatible with the chains we currently are connected to, but it's also forwards compatible, kind of future-proof, because it's forwards compatible with the chains that we're going to connect next without you having to change anything in your contract, which is pretty cool. Because you deploy a contract, let's say it's a cross-chain swap, let's say we add Filecoin next. Your contract is compatible with Filecoin now. You didn't have to do anything. And Filecoin now is compatible with Bitcoin, and all of them are compatible with each other and live happily ever after. So that's pretty cool.
Got it. Thanks.
So one thing, so when I'm transferring tokens to for the Omnichain call. So I need to get a approval beforehand of the token.
When you're sending ETH from Ethereum, you don't approve anything. If you are sending USDC on Ethereum, you kind of have to approve it in a contract. But no.
It's a transfer to the TSS address.
Yes.
Right.
Well, yeah. If you transfer USDC to your TSS address, you need to approve it once on Ethereum, but you don't need to approve anything else. So one cool thing you can do is you can do swap and withdraw to many chains. So let's say you have one ETH, you send it to your TSS address, and in the data field you say, I want Matic, I want BNB, and I want BTC. And your ETH gets swapped in native proportions to all these tokens, and these tokens get withdrawn to all these chains. And you just as a user, you just had to sign one transaction. That's pretty cool. So one transaction can trigger a bunch of transactions on other chains.